Okay, we are going to look at question number 7. So, we need to identify the key characteristics of the graph. This is a quadratic graph. So the first thing that we need to look for is we need to look for the vertex. The vertex in this quadratic is this point here. I said it's a point, so we need to write it as a point. So we're going to say our x value, we're going to go back up to the x-axis is 2, comma, and my y value, go back to my y-axis, is negative 1. So when we write our vertex, we need to write it as an x, comma, y. Well, this vertex gives us our axis of symmetry. We said before that our axis of symmetry is this line that cuts through our vertex. Well, we know that it's cutting through at x equals, and our x value is 2. This quadratic has a minimum. It has a low point. So any graph that has a minimum is going to be concave up because it has this low point. It is a maximum if it is concave down because it has a high point. The min or the max tells you how low or how high the quadratic goes. So we're talking about the y value. Our y value in this quadratic is negative 1. When we talk about y-intercept, we talk about where our graph crosses our y-axis. So we're going to go to the y-intercept, which is this line here, and or our y-axis, and our graph crosses our y-axis at 3. That is a point. So we're going to write that as a point. So we will say 0, 3. Roots can be used in 4 different words. We can use x-intercepts, solutions, or zeros. So we can use any 4 of these words to describe the same thing. We're talking about where our graph crosses our x-axis. Well, our graph crosses our x-axis at 3 and at 1. So we'll say 3 and 1. Domain talks about what are all of our x values in our quadratic. And for a quadratic, it's super simple. A quadratic's domain is always all real numbers. The range talks about all the y values, all the y points on our graph. Well, there's lots of y values, so we have to say y, and we got to look to see where it cuts on our y. Well, we said here's our y value of negative 1. Our whole graph goes above that y value. So we're going to have to say y is greater or equal to negative 1, meaning all the y values are greater than that negative 1 value. Now, if we have a quadratic that opens the other way, so if it goes concave down, we would draw a line across and everything is below that y value. So that one would have a range of y is less than or equal to whatever my y value is. And we've already talked about this a couple times, but this graph is concave up, whereas this graph down here is concave down. Okay, now you try. Go ahead and answer the following questions. Okay, let's try. This is the second one. Go ahead and answer the following questions.